Anyway, let's get this class started and we'll see what we have to do. I need to do this. I need to close this application right here because you guys don't need to know that I'm going to a funeral tomorrow. And then let's go and, you know what I'm going to do is, a lot of you have been having troubles with the homework. So I want to talk about the homework and go over some of those questions that you guys might have. I sent an email out this morning because I checked the grades. Now here's some things that you guys didn't do, okay? And I'm recording this session, so hopefully you guys will be able to hear this. If you go down to like one of the first assignments that I have, which is watch past archives, I give you 5 points, and I think that I don't even know what I ask you to do. I think I give you just straight up 5 points. Let's see. What do you got to do for this thing? Oh, I give you 5 points for saying, did you follow the instructions? True. And the instructions were to go through all of these, or go through all of the archives from this past assignment sections and watch the ones you feel like you could do good on reviewing. So, what you're going to have to do is go through these ones and click on all of the watch assignments. Watch that. There's another one here. Watch there, watch there, watch there. Basically anything that has points. And if you don't want to watch all the videos, which I don't necessarily think you need to, but I want to make sure that at least you're thumbing through it to kind of like say, hey, I took a look at it. Just click true and go through it. That's free points. You want to know the crazy thing? Is half of you didn't do it yet. Grade checks are coming out. But half of you didn't go through and get these free points. I put this as 5% of your grade because I kind of wanted to give you guys a gift at the beginning of the year. So I need you to do this by tomorrow. At the very least, go in and click true on everything and then go back and watch the ones you want to watch. But at least get the points, because if not, I'm giving you zeros. Did you guys hear me? Are we cool with that? You guys understand? Okay, cool. Awesome. So that's free points. All right, next thing. I noticed that some of you didn't do that well on this retake of the final exam. It's 20 points, and that is also under the past assignment section. This 20 points, what we're going to do is, this is what I was going to say about it. One of you actually only got like 1 point out of it, out of the 20. I'll be honest with you, this is a multiple choice test, and you get unlimited tries. So there honestly shouldn't be any reason why anyone would get anything less than a 20. Although when I looked at it, very few of you actually got 20s. Let me just double check, because I keep telling you that it's a multiple choice test, unlimited tries. There we go. See, look. 20 points is in the past assignments group. You have 2 hours to do it. No, that's 4 hours to do it. And it's multiple attempts, yes. So I didn't even prescribe a number. I just said you're allowed to take it as many times as you want. Attempts is unlimited. So if there's only like 5 options, then really, at the very worst, you should take it 5 times, and it shouldn't do, you should be able to pass this quiz. So, technically, that's another freebie points that I don't think you guys are taking advantage of. I'm not yelling at you, per se, but what I am doing is I just want to make sure I point this out, because grade checks are actually due today, but I'll hold off until tomorrow. Sound cool? So let me know. Yes, I can hear you. All right, good. By the way, some of you guys are actually seeing, hey, do we have an exam coming up? No. This is next month in February, like a month from now. I felt like I've really been on the ball with getting your assignments out to you already and recording your videos beforehand. That I actually made your midterm exam. I didn't make it so you guys can see it, but it's when I'm taking a look at it in my thing, it's there. And I'm just giving you guys a heads up, like that's what's coming up. I'm going to adjust the due date for that when we get closer to it, because maybe we might be on schedule, maybe we might not be on schedule. So we're good there. All right. Some things about grading, and let's talk about this real quick. And I wanted to spend the first 15 minutes of class just catching up with you guys, making sure that you guys understand my new format, my new style. I don't think it's that bad, but then again, I'll admit to you that this computer program has been funky sometimes, and it's been messing with you guys' scores as far as, like grading. And I've gotten a lot of emails from you saying, hey, I'm having trouble putting in this answer because I'm sure that it's correct, but the computer keeps saying it's wrong. Well, there's one of three scenarios that actually happens. The first scenario is you're just straight up wrong. The second scenario is I'm wrong and I put it into the computer wrong. The third scenario is that you're right, but you're just putting it into the computer wrong. And I'll be honest with you, I'm not going to be all high maka and say I never make mistakes, because I totally do. I would actually honestly say that it happens each thing happens about a third of the time. A third of the time I'm wrong. A third of the time you're wrong, you actually didn't do the problem right. And then a third of the time you're right, but you just didn't know how to put in the problem correctly. So let's make sure we resolve all of those things. So here's the thing. If you guys ever email me and say, hey, Mr. Dalday, this needs to be fixed, this problem is wrong, I'll go back and check it. If I was actually wrong, I'll give you the points for free. Not only that, but I'll give everyone who tried the quiz before that those points for free. Or what I'll do is I'll fix it and say, hey, could you try it again, just so I can make sure that the computer is grading it correctly. And then you can go back and retake it. All of these quizzes are unlimited tries. All right? Everything I make from this point on, I decided to make it unlimited tries, except for maybe the test. All right? Now, some of you were having trouble on this one, Rat 1, page 5. This one, you were having trouble with the -2, and you guys emailed me back. Well, what I did was I went in, and everyone who took it, I gave you guys a 7 out of 8. If you just took it, I gave you a 7 out of 8. Even if you got like 1 or 2 points, I gave you a 7 out of 8. Because I screwed up. I don't know if I screwed up, but the computer screwed up that quiz so badly that we just kept going back and forth for a whole week. That I just said, you know what? I'm just going to give everyone who took the quiz 7 out of 8. All right, that's my gift to you. Okay? This one over here on the 20th, can you guys still hear me? Okay, I need you guys to respond back to me when I ask you questions, or every so often. It just makes me feel like I'm not talking to myself or thin air. This one over here, this Rat 1, page 6, have you guys been having trouble with that? Has there been any things where you're sure you got the right answer, you double-checked it, triple-checked it, and the computer's still saying you're wrong? The reason why I ask is because the highest a handful of you got was a 20 out of 24. And so I'm wondering if there were 4 points in there somewhere that you guys weren't getting because the computer was wrong. I'm going to wait for you guys to respond back to me. Have you guys been having trouble with it, yes or no? Okay. Savannah, why don't we talk about that one? Why don't we figure out exactly how I want you to input the answer? And then what I'll do is, here's what I did, all right? I looked at that today and I said, hey, my best students got a 20 out of 24 on this one. So what I did was I went in and I added 4 points to everyone's score. Everyone who took the test, I added 4 points. So whatever you got, if you got a 1, I added, you now got a 5. If you got if you previously got a 13, you now have a 17. I went in and manually added 4 points to everyone who took the quiz. If you got a 0, which means you didn't take it, I didn't add nothing because you didn't even try. So why should I give you points for not even trying? You know what I mean? You got to get those points, legit now. But I added 4 points just to kind of offset it, to say that, like, I recognize that maybe there might be some mistakes. Let's go in and fix those mistakes, but I'm going to give you guys the benefit of the doubt. So, what do you guys think of that? Is that all right with you? Okay, cool. So, yeah, and then if you got a 20, then you end up getting a 24, which is a perfect score. So that's kind of my reasoning behind that. So if you go in and look at that quiz again and you realize, hey, wait a second, I thought I got a 10 on this quiz, and then you see that it's a 14, then that's your reason why. Plus, another thing that you might want to know is that I rounded up. So a lot of times this thing is going to give you a 14 and a half or something like that. I basically just rounded it up to the next whole number and then added that. Partially because I was trying to be nice, partially because I was too darn lazy to put in the put in the decimals, so I just rounded it off. All right. Anyway, let's take a look at this thing right here, and let me ask you this. Oh no, not today. I forgot to tell you. Not today. I'm sorry. Which one of these did you have trouble with? So here's the quiz. Were you guys having trouble with this one? Which one of these were you having trouble with? Pretty much everything. I only got partial credit. Okay. I think that maybe you just maybe not know how to put it into the computer correctly. Let's try this problem out for size. All right, here's my scratch paper. Let's find a blank spot for me to do some work. All right, here we go. 1, 5, 10, 11. All right, well, why don't we try 5 on for size? Cool? Let's take a look at it. And then what I'll do is I'll take a look at it. I'll take a look at what I told the computer to grade as correct. And then I will, I'll solve it out with you. Then I'll take a look at what I told the computer to say is correct. And then if I got it wrong, of course, I'll give you guys the points. If anything, know that your teacher tries to make as little mistakes as possible. I admit to making a lot of mistakes, and I don't mind doing that, admitting that. And please know that your teacher is more than willing to always correct the mistakes that I make. Anyway, let's take a look at this one. 6 minus x plus 4 over x minus 2 times x plus 3. Okay. So my common denominator here is I would consider that as 6 over 1. All right? Then what I would do is I would say, all right, what is a denominator that's in common between this one and this one? I mean, I just covered adding and subtracting fractions with my 5th grader yesterday, last night. So the thing that's in common is the x minus 2 times x plus 3. Cool? Yeah, you basically multiply the two denominators together. Now, what is missing from this 6, from this denominator, to make it into that denominator? Well, the whole parentheses part. So I need to multiply the 6 by that parentheses part. Are we cool? Now, what is missing from this second denominator that's in my common denominator? The answer is nothing. 1 second. I got a problem. Hold on. Check.
Check.
Hey, sorry, did I get kicked out of the audio there for a second? Can you guys hear me? Alright, yeah, I'm sorry. I fixed it. Hopefully that works better now. You guys can still hear me, right? Kaylin, you're absolutely right. You multiply this second numerator by 1. Or basically, you don't change it at all. You just kind of slap on a minus x plus 4 onto there. Notice how I put the parentheses in there because what I want to do is make sure that I distribute that negative. So what I'm going to do with the numerator is I'm going to FOIL it out. I've got 6 times x squared plus x minus 6. I'll be honest with you, I did a step in my head. Are you guys able to FOIL that out quickly enough? If you want, I can FOIL it for you, but you know, can you guys hang with that? Are we cool with that? All right, now I'm going to distribute in this 6. I'm also going to distribute in this negative. So in the numerator, I have 6x squared minus 6x minus 36. I'm sorry, not minus, it's plus 6x minus 36. Over here, I have minus x minus 4. X minus 2, x plus 3. All right. What I'm going to do is I'm going to do this. I'm going to combine like terms in the numerator. Now in the numerator, I can combine the, okay, I'm going to start working up here because I'm running out of room. 6x squared plus 5x minus 40 over x minus 2, x plus 3. Did I do that correctly? I think I did. Yeah, sure. What I'm gonna do is I'm gonna ask myself, can I factor this thing down a little bit? And I think the answer is no. I'm just gonna straight up say it's no. The reason why I want to factor that out is because I want to see if anything in the numerator will cancel out with anything in the denominator. But I don't think that it can, so what I'm going to do is I'm going to get this thing ready for my answer. Now my answer, I'm going to FOIL this thing out, FOIL out the denominator. So I'm going to keep the numerator the same. I'm going to FOIL out the denominator, and so I have x squared plus x minus 6. So if I were to compare this to this thing right here, then what I would say is if I were to compare this to a x squared plus b x plus c over a, or d x squared plus e x plus f, what I want to do is I want to have the computer take the numbers. So I would say the numbers is, the coefficients is, for a is 6, b is 5, c is negative 40, d is the number 1, e is the number 1 as well, and f is the number negative 6. So I'm going to take a look at right here and ask myself, well, what did I tell the computer the correct answers were? All right, I told it A was 6, that's good. B was 5, is that correct? Yeah, that's what I said. All right, let's see. C was negative 40, yeah. D was 1, E should be 1, and F, I said it was negative 6. Is that correct? Yeah. Okay. How many of you, all right, here's my question. Did you have trouble with this problem because you didn't know You were able to get here, but you didn't know how to input your answer? Did anyone have that trouble? I want a yes or no. So that means technically everyone should answer. Yes, I had trouble. No. Okay. So Kanani, it looks like maybe you knew how to do the problem. You just didn't know how you wanted me to put it in. All right, that's fair enough. Now I got a question. For those of you who said no, I didn't have any trouble. Does that mean you didn't have any trouble at all with this problem, or you guys weren't able to even get here? Now, keep in mind, we're all friends here, so you don't need to freak out if you didn't get there. Okay. All right, that's fair. That's fair. No one's going to tease you. Okay. Do you know how to get there now? Do you know how to do it now? Do you want me to do a few more for you? You guys are thinking, shoots? He's going to do our homework for us? And I'll be like, all right, fine. I'll do a few of these. This is your reward for coming to class, all right? I'll admit I won't be doing all your homework for you, but I'm going to do a few of them. Let's do this one. Number 10. Let's see if I can find a nice space for me to work. All right, here's the problem. Okay? I'm going to use this area to work. All right. What I'm going to do, and actually, to be honest with you, I actually really enjoy this, and I felt like I honestly feel like the videos that I recorded were really good. They were good. I don't know, were they junk or what? Maybe I went too fast on them. All right. Here's your opportunity to ask me questions. Check this out. Ready? All I'm going to do is I'm going to deal with this division sign first. I'm going to change it from a divide, and I'm going to change it into a times if I reciprocate what I'm dividing by. Are we cool with that? So these are the same. I just took the second fraction and I flipped it over on its head. That's how you deal with that. All right? Okay. Second thing I'm going to do. I'm going to factor the heck out of everything I possibly can. So let's factor this top one over here, the top left-hand corner. I've got an x there and an x there. I know that I'm going to have a plus and a minus. I'm honestly thinking plus 8 and minus 1. Everyone agree? You guys know how to do that, right? How to factor that? Okay. Over here I have an x plus 8 on the denominator. I can't really factor that. That doesn't do anything for me. Over here I have an x plus 5. And over here I'm going to factor out a 9. Because there's a 9 in common with both of these. This is the bottom right denominator. So I have 9 times x minus 1. Are we cool with that? Okay. All the things inside of the parentheses cancel. So x plus 8 will cancel out with that x plus 8. And this x minus 1 will cancel out with that x minus 1. So what I'm left with is x plus 5 over 9. We cool? What I want you to do with this is I want you to compare this to ax squared plus bx plus c over dx squared plus ex plus f. Now, I see no x squared terms. I see no x squared terms, so I would say a is 0 and d is 0. Because I'll put a 0 in front of those things, and that will kill that x squared term part. Over here I have bx. Well, that's just the coefficient in front of the x is a 1, and the c is 5. On the denominator, I only have a number that doesn't have an x by it, so the e is 0 and the f is 9. Let me just double check. I should have 015009. Alright. So for question 10, alright, let's see. Question 10, that was this, which one? This one right here. I have 0 is A, B is 1, C is 5, D is 0, E is 0, and F should be 9. So, I'm sorry to say, but for both of these problems, actually, I did it right. You guys maybe you guys were able to do it, but you guys didn't put it in correctly. Now I got a question. Just and all I'm doing is I'm just kind of taking a survey as to where you guys are at. Were you guys able to get to this point right here? Could you guys do that? Okay. I got some yeses and nos. All right, that's fine. Do you now know how to do this? This is important stuff. Okay. Now I got a question, and it's just me asking. Oh, you couldn't simplify the x squared plus 7x minus 8. I'll be honest with you, Savannah. I remember giving you those kinds of problems in semester 1, and I gave you a whole bunch of them to do. And I told you back then, and I'm not trying to like harp on you and say, oh, you know, you should have learned this back then. Well, I kind of am, and I guess that might be, if I'm being a jerk, I apologize. But anyway, I remember telling you guys that I'm going to give you guys a lot of these problems just so you guys can get good at this. This is the reason why I want to give you a lot of those problems so you can get good at it, because I want you guys to be able to hang with this. Savannah, I'll tell you what I'll do is, why don't we factor out this one right here. X squared minus 10x plus 25. We want to factor this. Okay? So over here, we want to ask ourselves, what times what gives us an x squared term? And that would be x times x. Okay? I remember making you guys do like 100 of these problems or some ridiculous amount. Maybe I did, maybe I didn't, but you guys should have done a lot of these problems. If not, I can always go and give you more problems to do so you can get good at it. But then again, you know, I'm not trying to make you feel bad about not knowing how to do this. I'm not trying to punish you at all. But I do want to make sure that you guys have gotten good practice with this. Anyway, let's talk about this, the rest of this one. What we're going to want to do is, we know, okay, so next thing we're going to do is, there's going to be a sign in there. That's S-I-G-N. So it's either a plus or minus, or a plus and a plus, a minus and a minus, or a negative, all right, so there's 4 options. You can either have plus minus, minus plus, plus plus, or minus minus. Cool? Those are the 4 different combinations I can put into as far as the signs go. And then we're also going to have a number at the end, and I'll show you guys how to figure that out. The trick to knowing which signs to use is you look at this sign over here and this sign over here. Okay? If this second sign over here, and that's the first thing you look at the second sign over here. If that number is a positive number, then you know that it's either going to be a plus plus or a minus minus. The reason being is because only a plus times a plus will give you a plus. Or a minus times a minus will also give you a plus. But if you do a positive times a negative, that will not give you a positive number over here. Does that make sense? So, I have one of 2 options. I can choose the plus plus or the minus minus. Now, in order to distinguish between the two, what I would say is now look at this at the first sign right here. because I'm going to have to add these two numbers to get this middle number. Now, if this first sign is a negative 10, then I ask you, if I add a positive and positive, will I ever get a negative 10? No. Awesome. So the only way to do that is to make this a minus and a minus. Do you understand how I got that sign in the middle now? Alright, now what I do is I take a look at 25 and I want to plug in numbers into here, and they have to be factors of 25. So there's really only not that many factors of 25. It's pretty easy. You got 1 and 25, and you also have 5 and 5. I think obviously you would choose the 5 and 5 because after you've chosen the factors of 25, you need to choose, well, which numbers can I combine to get the number 10? Obviously, you can't really combine 1 and 25 in any way in terms of addition and subtraction to get close to 10. So the answer would be 5 and 5. So if I plug in 5 over here and 5 over here, that's how I factor this. Cool? Now, I'm sure that some of you did it in your head pretty quickly, but hey, all right, calm down. Savannah's our friend. We should be able to say, hey, we can slow down. We can help her out. Now, by the way, if I want to factor this thing over here, 10x minus 100. In this case, there is no x squared term, so I see no need to do that factoring game. But what I would ask myself is there a common number is there a number I can divide 10x and 100 by nicely? And the answer is 10. You can pull out a 10. So this second term over here, this becomes 10 times x minus 10. Because if I distribute this 10 back in, I would get 10x minus 100. Are we cool with that? So not all factoring needs to be done with these parentheses, these giant parentheses, where you got to play this game of figuring out which 3 terms to go in. And I actually just gave away all the secrets, to be honest with you. I just gave it away. I told you all the things you really need to know about factoring those things, the pluses and the minuses and all that kind of stuff. What I like doing, the way I like teaching it, in fact, I even feel like I've done it with you guys, is I like giving you guys like 100 problems and then just making you guys figure out your tricks on your own. Because I'll be honest with you, you tend to remember your tricks much longer and much better if you are able to, you tend to remember them if you make them up yourself. And the way I'm teaching you math is the way I learned how to teach myself when I had to do like 1,000 problems. I actually straight up think that my teacher gave me like 1,000 of these problems to do, and I just learned how to do it real quickly. It will serve you well later on in life, I promise you that, if you tend to go into math that's higher than Algebra 2. I mean, even in Algebra, I mean, this is Algebra 2, but if you tend to go on math, this will serve you well, so learn how to do this. Okay? Alright. Let's talk about this thing. I didn't even talk about new material yet, and I don't mind. To be honest with you, I feel like maybe the best place to cover new material would be in my watch videos when I record those beforehand and have you guys watch those. And then what I should do in the WebEx classes is just kind of catch you guys up with anything that you guys were confused about. So that actually means, okay, all right, that actually means that you must watch the videos before class. Now let me ask you this. Did everyone watch Rational Functions 2 before class when we talk about vertical asymptotes? Oh, good. Awesome. Savannah, Kaylin, yes? All right. If you didn't answer, either I'm assuming you said no or you just don't want to answer. We talk about vertical asymptotes What an asymptote is a line that approaches a number but never touches it. And these asymptotes can either be horizontal or vertical. Now, usually you talk about vertical asymptotes when you have a domain issue. Now, if I'm speaking complete crazy to you and you guys don't understand anything that I'm saying, make sure you guys watch these videos. Because really what I'm doing is I'm recapping this. I'm not like introducing asymptotes for the first time to you in class. But let me explain this to you. Like, I'm going to make up a problem. What if we have 1 over 3 minus x? Or I'm sorry, how's about we'll go 1 over x minus 3. Okay? Excuse me. 1 over x minus 3. There's a domain issue here. Okay? The domain issue that we have is x minus 3 cannot equal to 0. The reason why we would have a domain issue in the first place, give me a second, I need some water. I'm getting over a cold, so I need to keep my throat like hydrated or else I'm going to start coughing. Alright. The reason why we would have the domain issue in the first place is because we have a fraction. And whenever you have a fraction, you must know that the denominator is never allowed to be 0. That's why I said the x minus 3, which is the denominator, cannot equal 0. You guys remember this, right? We covered this last year. Yes, no? I can't hear you. I'm not listening. Awesome. Okay, good. Just making sure you're alive. Okay. Which basically says that x cannot equal to 3, right? Because if x is equal to 3, then what you'll have is you have 1 over 0. And 0 cannot be in the denominator. We've established that. Now here's my question. Can x equal to 2.99? Is x allowed to equal 2.99? I'm confused. Let's see. Kaylin, you said no. Did Savannah, did you say yes or do you say no as well? To be honest with you, Kaylin, I don't know. I don't see why not. Because here's the question. 2.99, is 2.99 exactly 3? No. And I just said x cannot equal to 3, but I didn't say it can't equal anything close to 3. I just said it can't equal exactly 3, right? I mean, if you plug in 2.99 into here, you'll have 1 over 2.99 minus 3. 2.99 minus 3 is negative 0.01. If you don't believe me, use your calculator. But I mean, that's pretty easy to do, right? That's equal to negative 100. So, granted that it's a big number, or it's actually a really, really small number. It's a big negative number. But there's nothing wrong with negative 100. Are we cool? So, there's nothing wrong with saying, hey, x cannot equal to 3, but x is totally allowed to be 2.99, right? X is also, here's my next question, is x allowed to be 3.01? Sure, why not? That would just give me 3.01, that would be 3.01 minus 3, which would end up being 1 over 0.01, which would end up being, if you use your calculator, 1 over 0.01, it's 100. So it's a big number, but it's a number
nonetheless. However, if you plug in straight up 3, then you have a problem. You see what I mean? If you plug in straight up 3, then you'll have 0 in the denominator. Okay? Now, I'm actually going through the advanced version of the asymptote, but I'm going to baby step your way through it, so I want you guys to be able to understand it. I might be taking a different approach than what my previous video is taking, but at least maybe then you'll be able to see this from a few different angles. Cool? Okay. Can you guys hear me? Yes, no? I want to make sure you're live. All right. Kaylin, I didn't. You haven't been answering, so I just want to make sure I didn't upset you, right? By saying no, you cannot. I mean, the answer was no. I mean, you're totally allowed to put 2.99 in. I just don't want to offend you. All right, cool. All right, awesome. Besides, yeah, I mean, I'll be honest with you, and yes, this is probably going on the recording, and yes, I probably shouldn't say this, but I really like having you in class. I mean, I don't know why I shouldn't say I like having you in class. It's just I really enjoy the students who come in all the time, and you three are definitely that group, along with Erica, which I have no idea where she is this time around. But I mean, I've got some of my core students that I really appreciate you guys coming in, and I want to get into like really deep, good mathematics with you guys. But I like talking with you. I might tell you you're wrong, but I'll try to be as encouraging as possible. Anyway, here's what my next question is. If I make x equal to 3.0000001, am I allowed to do that? Can x be 3.000000001? Sure, why not? It would just be, I mean, yes, granted, it's really close to 3, but it's not exactly 3. If it were exactly 3, it's bad. But if it were really close to 3, we're fine. Now, here's my next question. Do you think the number that it's going to equal is going to be bigger or smaller than 100? This one you got to think about. All right, Savannah's saying bigger. Okay, all right. What's your thoughts, Elijah, Kaylin? I don't mind waiting. Is it bigger or smaller? All right, we got some bigger people. All right, so check this out. Here's kind of my reasoning behind this, and here's my logic, all right? This number is really close to 3, right? So when I take the difference, or when I take my number that's really, really close to 3, and I subtract 3, I'm going to get a really, really small number. Do you guys agree? Okay. If I get a really small number, that means that there's going to be a really small number. And where's that really small number going to be? It's going to be in the denominator. So it's x, or 1 over a small number. I should rewrite that. Small. If you have a really small number in the denominator, what happens to the number as a whole? It gets bigger. So the smaller my denominator gets, the bigger this thing gets. Or the closer my number gets to the number 3, the bigger this answer is going to be. Do you guys agree? You guys see my logic here? So as I get if I were to graph this, I would put a dotted line here at 3. That dotted line represents my asymptote. As my graph comes in over here, as it gets closer to 3, it's going to explode up like that. It can never touch exactly that dotted line because I can never get x to be exactly 3. But I could get it closer and closer and closer to 3. And as I get the x closer and closer to 3, at least from the positive side, this thing is going to get more and more bigger. It's going to go up to infinity as you get infinitely close to 3. You'll never reach 3, but you'll get very, 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 very close. I'll be honest with you, this is the beginnings of calculus. You guys are tripping out because you guys are thinking, dude, we're learning calculus? And I'm like, yeah. You guys are straight up learning calculus. I don't know why I went into gangsta talk. Alright. Now, on this side, when I made it 2.99, so it would be approaching x from the left-hand side, this thing was negative 100. So the graph actually looks like this. As you get closer and closer from the left side, this thing is going to get more and more negative. Your graph is actually going to look like this. It's going to go close, and then it's going to spike down, and then it's going to come from the right-hand side. It's going to come in and spike up right at 3. It will never touch this this vertical asymptote, but it will always get really, 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 really close. Does that make sense? So I'll tell you what, why don't I switch over to Desmos and I'll see what the Desmos graphing calculator does. Desmos graphing. Do you guys use Desmos graphing calculator? In fact, I even made sure that it was uploaded to your thing. Yeah, hey, I have no problem with that. I don't think it's cheating. I think you guys can use it. I don't mind whatsoever. Anyway, if I were to graph 1 divided by x minus 3, you look at this thing right here, and right at x equals to 3, see how the graph explodes on the right-hand side, positive, and it dives down negative on the left-hand side. I can zoom out as much as I want, and you can see that the graph just kind of shoots up over there and shoots down right at x equals to 3. Does that make sense? Now, what if I change this from x minus 3? I don't know why it displays it funny, by the way. To x minus 4. All that does is it moves my vertical asymptote out to positive 4. And we're kind of going through that same right and left crazy rule. Excuse me. Where if it's x plus 2, it actually moves it to the left 2. You guys remember this game that we played when we were graphing parabolas, right? If you have a plus 2, it actually moves it to the left. When you're moving right and left, it does the opposite of what you actually expect it to do. That shouldn't surprise you. All right. So are we cool? You guys are now dubbed experts on vertical asymptotes. All right, let's see. I pretty much discussed everything with you. I just kind of did it in a way that I don't know. I thought it was more philosophical, but I think it makes sense. One of the things you need to be careful with is notice how you have. All right, what if we did this? Let's go back to Desmos. So what if I did x plus 2, okay? And then I compare that to 1 over x plus 2
but I put a parenthesis, x plus 2, okay. I put it inside of a parenthesis and I square it. Here's what I want you to realize, all right? I don't really want you to take into account the different shapes, but I do want you to take into this account over here. When I have 1 over x squared, my graph goes, instead of going on the opposite side like this, like say the vertical asymptote is right at 0, instead it actually goes like this. And when I talk about it in my video, I basically say, on the left side it goes up to infinity, and on the right side it also goes up to infinity. Now that's different from when you have 1 over x plus 3. That graph would look something like this, and I'll do that in purple or blue or whatever. On the left side of this asymptote it goes down to infinity, and on the right side it goes up to infinity. It makes this weird jumpy thing when this power over here is an odd number. When the power that you're raising it to is an even number, then it will do this thing where it ends and starts in the same direction. Does that make sense to you? Okay. I just want you to notice that. Like here, let me show you on Desmos. What if I had, all right, I'm going to delete this one right here. What if instead of having a 2, I have a 3? Then look, what happens is your vertical asymptote still occurs at x equals -2, okay? The graph is a little bit steeper, but the asymptote is still the same. It will still go up to infinity at x equals 2 and down to negative infinity at x equals -2. But now that I have to the third power, it kind of does this opposite jump, where on the left side it goes down to infinity, on the right side it goes up to infinity. Whereas if I made it to the fourth power, then on the left side it goes up to infinity, and on the right side it goes up to infinity. Notice, same vertical asymptote. It's still at x equals -2. There's like an imaginary dotted line right here. Maybe I can draw that dotted line in. Maybe what I'll do is this. X equals 4. No, x equals 2. No, x equals -2. See, this green line, this green line would be a graph of my asymptote. So if I made it to the 5th power, let's zoom in a little bit. If I made it to the 5th power, it's going to make that opposite jump again. So it's still going to approach this green line as I get closer, but it's going to go down on this side and up on the right side. And if I make it to the 6th power, you guys see the game that we're playing here? Hello? Yes, no? Alright, cool. Alright, I wanted to make that observation with you. Alright, let's talk about... Does anyone have any other questions about asymptotes? Okay. I tell you what, technically I have you till I put on the class that I would finish at 9:40, and it's now 10 o'clock. Technically, I should have you guys till 10:25. I don't mind hanging out. I'm going to ask you this. What direction would you like to go at this point? Would you guys like to just go home and work on your stuff? Or you're already at home, but I mean, would you guys like to just log off and work on your stuff? I'm fine with that. Would you guys like for me to talk about rational functions 3 because this one is a little bit confusing. It's not even that bad, to be honest with you. And I recorded a video on this one, so you guys should be able to watch those. Would you guys like to just leave and then watch the rational 3 functions before I talk about it? The reason why I'm giving you this extra time is because we missed so much of lecture last week that I feel like I have to make up for some. I'm going to leave it up to you. What do you want? You have some work to do today? Alright, so I'm assuming you want to go now and finish your work. Because I think technically rational functions is due like, this rational 3 is due like next week or something like that. Alright, let me just check to make sure that this thing is due. Alright, sounds like you guys are in consensus. Let me just check something and I'll let you guys go. So, this stuff is all due like at the end of this week and next week. Obviously, I'll tell you what I'll do is, I'm not going to push the due dates back, but I won't include this in this week's grade check, rational 3. So, can you guys turn, this stuff in next week? Yeah, I'm fine with that. I'm totally fine with that. Alright? I'm not going to kill you for that. But I do want to make sure you guys watch the videos before I lecture on it. We cool? Alright, and I hope that stuff was helpful to you as far as like me going over the homework and showing you the format I wanted it put in. I think what I'm going to do is I took a look at it again with you guys in class, and it looks like I actually put it in the computer correctly. You guys just didn't know how to input it into the computer. So I'm going to let you guys retake that, but I need you guys to do that by tomorrow. I'm talking about rational, like chapter 1 stuff. In fact, to be honest with you, I just want to take a look at this one, and then, well, actually, you know what? You guys are totally allowed to go. Yeah, this is pretty straightforward. Yeah, we talked about how to do this one, so you guys should be able to do this one. It's pretty simple. It's only like 5 points total or something like that. Alright. Okay, I think that's good. I'll talk to you guys later. You guys take care. Okay, bye.